Our last example. So we read through this one. It was a short read, I think, at the end of last class. It's got a lot of information. So we need to start off by organizing this. So I made this matrix A to organize my data. Now, based on that matrix A, I have my budget, the economy, executive, and the presidential models along there. So they are all in the rows. And then I have the transistors, capacitors, connectors, and dials along the top. So based on that, if I'm going to make a matrix B of the amount per day, I'm going to make it a 1 by 4 so that the beep that's in the is up and down in the first matrix, it's the opposite in the second matrix. So that my columns in my matrix B stand for beep, and my rows in matrix A and that's going to become important because if I want to multiply them, it will now make sense. If I do B times A, B is a 1 by 4, where the 4 stood for beep. And the A is a 4 by 1, where the 4 by 4, sorry, where the first 4 stood for beep. And it's important that those things match up. Because if they don't match up, then you could create a matrix where you do matrix multiplication and every single number in your answer means absolutely nothing. Has no real life application. They're just made up numbers that mean nothing. But if those numbers in the middle do match up, your answer will be a 1 by 4. What did the 1 stand for? It stood for per day. And what did the 4 stand for? That's our transistors, capacitors, connectors, and dials. And now we know how much per day we need of each of those things. And so the matrix multiplication allows us to get that data quickly. So if you put this into your calculator as matrix A, this one is matrix B, I would store this one as matrix C. So we can take these answers right here is basically the answers to part question A that we have there. You're good? Okay. And then for question B, if they want to increase production by 40%, well, that would be just multiplying by 1.4. Then you would need this amount per day. And you might actually think to yourself, can I make 0.8 of something? Well, maybe you could. Maybe it could be on the conveyor belt and be 80% along, done, not quite done. So we could leave those decimals there. Or maybe you would just continue working until they were completely done. So then you might say, well, we'll make 10 of these, 17 of these, and maybe we'll save time and only make 15 of those. Wouldn't you like it if I got you to write out these questions instead of having it pre-typed? This question would take like 2 days. So again, we've got to make a decision how we're going to set up our matrix here. Because we know how many person hours it takes for each of these. So I could make that matrix either as a row matrix or as a column matrix. But if I want to figure out how many employees, or how many hours is needed per day, can you see that you're going to need to make your column matrix right here? Because we figured out you could either take B and multiply it by E, or take D and multiply it by E, because those are our matrices that we found out in the previous question, how many per day you're going to be making, either before or after. And then when we multiply those out, again, this one stood per day, this one stands for hours, and we get the total hours of people power that we need for those months in order to make them. So matrix multiplication, once you get the stuff into your calculator, you can do a lot of calculations quickly, just depending on whether your matrices match up. In other words, do the columns and the rows of different matrices have the same things? Because then you could multiply them together, and then whatever the outside thing stood for becomes your categories of your new answer. So per day, how many hours? We need 249 hours per day. People only work at this job only 7 hours a day, so if you took that 24 and divided by 7, you get 35.57, so you'll probably need 36 employees.